Hello guys, my name is Shubham Bise. My group partners are Mayur Harkal and Prasad Patil. Our topic is audio recognition and processing system. This topic is guided by Nutan Bansode ma'am. Guys, we have covered all these topics in this PPT. Overview of real-time application, overview of content of DSP, introduction to the audio recognition and processing system, brief of research paper, theoretical implementation of Butterworth filter, which we have used to implement this project. Implementation of this project on MATLAB, result with respect to real-time applications, conclusion of this project and references are the contents in this PPT. Okay, the introduction to this topic is, guys, we all know that audio recognition and processing system is a very important if we consider the industrial applications. Okay, in this topic, the audio is recognized by microphones in laptop or mobiles. The speech which is recorded is noisy. The speech which is recorded by laptop or mobile microphone is a noisy signal. So it is very important to remove the noise and get the actual information from the sound signal. This filtration is done by using Butterworth filter. We have used Butterworth filter to filter all the noise from the audio signal. Guys, we all know that audio in this audio signal, the low frequency signals are noise actually. All the noise which is there in the environment is a low frequency signal in the audio signal. So the main task in front of us is to remove the low frequency signal from the audio signal. Okay, the real-time applications of this project is in audio recognition system. In audio recognition system, this system is used in many industrial applications. If you consider the film sector, if we consider the musical musical sector, if we consider film sector, if we consider so many military application, in these applications also the audio recognition and processing system is used. Okay, audio recognition system is used in many industrial applications. Processing methods and application areas included storage of the audio signal, data compression, music information retrieval, speech processing, localization are in this system. This system is also used in audio detection, audio synchronize, audio broadcasting, active noise control, audio effect, etc. Okay, guys, we have taken some concept from DSP, which are sampling, IDFT, and Butterworth filter. Guys, we all know that sampling is the technique by which a continuous time signal is converted into discrete time signal. We all know that the audio signal is actually a continuous time signal, but for processing purpose we have to convert this continuous time signal into the discrete time signal using the sampling frequency. The sampling frequency is the frequency by which we can convert the continuous time signal into the discrete time signal. Okay, we have also used a IDFT technique here. The IDFT is inverse discrete Fourier transform technique, which is used to convert the frequency domain signal into the time domain signal. Guys, there are two types of signals, the frequency domain signal and the time domain signal. There are some techniques which are applicable only for frequency domain signal, and there are some techniques which are only applicable for time domain signals. The filtering is a technique which is applicable for time domain signals. So it is very important to convert this frequency domain signals into the time domain signal. So we have converted this frequency domain signals to time domain signal using IDFT technique. If we want to convert the time domain signal into the frequency domain signal, then there is a FFT technique, which is fast Fourier transform technique. Okay, guys, here we have used the Butterworth filter to filtering of the audio signal. The Butterworth filter is a type of signal processing filter designed to have a frequency response as flat as possible in the pass band. Okay, Guys, we have also taken a research paper. We have studied this research paper, which is published by IEEE on the same topic. The title of the paper is Whispered Speech Recognition System, Deep Denoising, Autoencoder and Inverse Filtering. The publisher of this paper is IEEE. The, there are two authors for this research paper. The topic which are addressed in this research paper are automatic speech recognition, deep denoising, autoencoder, and inverse filtering. The technology stack which is used here in this paper is MATLAB. We have calculated so many means important data like carrier frequency, sampling frequency, the order of Butterworth filter. We have calculated all this theoretically also. These are the formulas which are used to calculate the order of filter, the sampling frequency used to convert the continuous time signal into the discrete time signal. Okay, and also the carrier frequency. All these concepts are in DSP and we have calculated it theoretically, and then we have put the values which are coming out of this theoretical calculation into the MATLAB code. Okay, guys, here is a MATLAB code for recognition of audio signal. For recognition of the audio signal from laptop microphone or from mobile microphone. Guys, it is very important to enable the microphone. So the audio recorder is an inbuilt function in the MATLAB which enable the microphones and will record the audio from the environment. Okay, record blocking is also an inbuilt function in which the file name and 5 which is here is a time for which the microphone is enabled or for which the audio is recorded. Okay, now display play is actually an inbuilt function for calculation, for understanding of this system. Okay, means by using the play we can play the AQ audio signals like that. WN is a variable in which get audio. By using the get audio inbuilt function we have converted this AQ audio signal into the numeric format, that is amplitude and frequency with respect to time format. We have plotted this here here in this uh, PPT also, in this slide only. Okay, for processing of audio, our project is audio recognition and processing. We in previous slide we have recognized the audio from the environment. In this slide we are going to process that audio. Okay, the audio write, audio read are actually an inbuilt function in this MATLAB. Okay, FC which we have taken here as 800. This is a carrier frequency. Guys, make FC as higher as possible to hear the higher frequencies. We have used a Butterworth filter. Here there is a in MATLAB there is a butter as an inbuilt function to use a Butterworth filter. Now we have also plotted the filter signal. Guys, if you consider the previous slide, here in this slide, if you consider the frequency and filter and amplitude and filter, and in amplitude filter and frequency filter data, there is a vast gap. The low frequency signals are actually the low frequency signals which are there in audio unfiltered data are completely means removed by using this technique. Okay, that are noise signal. If you can see in this conclusion slide, if there is a amplitude and filter, frequency and filtered, amplitude filter, frequency filtered, thus the unused frequency, that is noise signal, are removed from the signal so that the audio signal and information in the audio signal remain unaffected. That is the main goal of our project. Okay, these are the references